In 1964, a team of Russian researchers led by Andrey Kapitsa from Moscow State University conducted a seismic experiment in the eastern part of Antarctica, near to the Vostok research station. They measured the thickness of ice in this region, unaware that there was something far more valuable and revolutionary that they were missing, right beneath their feet at a depth of 2.5 miles. By 1973, a new expedition of researchers from the US, the UK, and Denmark ventured to study the same location. This time, they made an incredible discovery that initially seemed impossible. What they found beneath the ice became one of the biggest geographical sensations of the second half of the 20th century. They uncovered one of the largest freshwater subglacial lakes on the planet, which had been completely isolated from the rest of the world for millions of years. It was named after the Vostok station and became the subject of extensive research, seeing how the things it might conceal could potentially change our understanding of how and in what kind of conditions life can arise and evolve, not only on our planet, but potentially on others as well. The lake is about 149 miles long, 31 miles wide, and 2,460 feet deep. In size and volume, it's not unlike Lake Ontario, which lies between the United States and Canada, with an area of 7,300 square miles. Lake Vostok has been completely cut off from direct contact with sunlight, wind, and surface life. Its complete isolation has lasted millions of years. The water temperature in the lake reaches about 10 degrees Celsius, indicating that the lake is heated by geothermal sources, likely forming a network with other subglacial lakes and creating a separate ecosystem that had existed alongside the surface ecosystem of Earth for millions of years. Moreover, the oxygen content in Lake Vostok's water is 50 times higher than in regular fresh water. And although the pressure created by the thick ice, around 300 atmospheres, is immense, it doesn't rule out the possibility of life existing there. Another remarkable feature of the lake is its dome-shaped air cavity, which rises several hundred feet above the lake. Soon after this astonishing discovery, drilling began in 1989. Only 23 years later, on February 5, 2012, at a depth of 12,365 feet, scientists reached the surface of the subglacial lake. The subsequent analysis of samples retrieved from the lake suggests that Lake Vostok might host a unique ecosystem surviving on chemicals from rocks rather than sunlight. After studying the water samples, scientists announced the discovery of a previously unknown type of organism. These organisms are believed to derive energy from minerals in the lake and the underlying bedrock. In addition, scientists discovered bacteria that are parasites of fish, leading researchers to speculate to this day that this may indicate the presence of unknown, complex life forms. The samples also contained psychrophiles, organisms that live in conditions of extreme cold, and thermophiles, which thrive in warm conditions, suggesting the presence of hydrothermal vents deep in the lake. But what if we told you that the discovery of bacteria beneath miles of ice on our planet suggests that life could also exist on other planets, even within our solar system? We can assure you these hypotheses are far from baseless. Such perfectly isolated lakes like Vostok may exist not only on Earth, but also on other planets and even moons in the solar system. For example, Jupiter's moon Europa has an outer layer composed of an icy crust, believed to be 6 to 18 miles thick, with a liquid ocean tucked away underneath. Scientists, particularly astrobiologists, believe that the conditions there might not be so different from those found in Lake Vostok. Similar subglacial lakes could also exist on Saturn's moons and even at the poles of Mars. The incredible phenomenon of Lake Vostok offers hope for the discovery of possibly even complex life forms of underwater life within our solar system. Today we know of 150 large subglacial lakes in Antarctica, and these are not only the potential homes for unique life forms on this white continent. Let's not forget about volcanoes, specifically the largest active volcano on Earth, located in the heart of Antarctica, Mount Erebus. Standing at 12,440 feet, it's remained active for about 1.3 million years and may help provide evidence of a hidden world that we can only imagine. Mount Erebus features a complex system of steam-carved ice caves. These caves were studied during extensive research conducted by the Australian National University. Scientists discovered that volcanic steam melts passages within the caves while traveling through open gaps, creating a unique system conducive to life. The temperature inside these caves can reach 25 degrees Celsius. It's hard to imagine that in the heart of Antarctica, with its extremely cold conditions, there can be a place where you could comfortably stand in just a t-shirt and shorts. DNA analysis of the soil samples from these caves revealed evidence of organisms being present, including algae, mosses, and small invertebrates. These findings offer a tantalizing glimpse of what might lie beneath the ice in Antarctica. Researchers don't rule out the possibility that these organisms could include new species of animals and plants. Despite the fact that there are only 2 active volcanoes on the continent, including Erebus, Antarctica is dotted with fumaroles, volcanic vents that release gases and vapor into the air. These could also create similar steam tunnels where previously unseen and unknown life forms may exist. Over the course of research aimed at studying Antarctica's sub-ice environments, another unique discovery was made by accident, triggered by the detection of a strange gravitational anomaly. Back in the 1950s, French and American scientists conducting comprehensive geological studies in the eastern part of Antarctica, in the so-called Wilkes land region, recorded a positive gravitational anomaly. This anomaly manifested as a regular gravitational strength in certain areas. Gravity in these spots was slightly stronger, which could indicate the presence of dense structures beneath the ice, responsible for the increased gravitational force. At that time, the area of this anomaly was outlined, surprising everyone with its shape and size. A circle with a diameter of 150 miles. This gravitational anomaly was strikingly similar to those observed near large meteorite craters. As a result, scientists hypothesized that buried beneath the massive Antarctic ice sheets might lie the largest asteroid crater on Earth. In 2002, NASA satellites studying Earth's gravitational field as part of the GRACE program received data about changes in Earth's gravitational field in the Wilkes land region. According to refined calculations, this anomaly was a staggering 300 miles in diameter. The approximate age of this gigantic crater is estimated to be about 250 million years, suggesting that this asteroid impact might have triggered the Permian mass extinction, which occurred around the same time and remained the largest extinction event in Earth's history, wiping out 96% of all marine species and 73% of terrestrial vertebrates. The Wilkes land crater is so enormous, it's almost 3 times the size of the Chicxulub crater, which wiped out the dinosaurs 66 million years ago. The asteroid that crashed into Earth back then was 6.2 miles in diameter, whereas the Wilkes impactor is estimated to have been 5 to 6 times larger, with a diameter of 30 to 37 miles. There are alternative explanations for the formation of this giant ring structure, such as large-scale volcanic activity. However, scientists lean more towards the asteroid hypothesis due to the greater amount of supporting evidence. But don't let the idea take hold that everything worthy of your interest on this white, ice-laden continent must lie beneath massive ice sheets. Something extraordinary is happening in Antarctica as we speak. The world's largest iceberg, known as A23A, is on the move. This giant iceberg first appeared in 1986, breaking off from the edge of the Wilkes ice shelf in the western part of Antarctica. However, initially it didn't move very far, grounding itself on the seabed in the central Weddell Sea. It remained stationary for about 30 years. It only resumed its journey in 2020, and it's now located near the South Orkney Islands. The iceberg covers an area of approximately 1,610 square miles, larger than the combined area of 5 New York cities, or equivalent to the combined size of Moscow and London. The average thickness of the iceberg is around 920 feet, and it weighs about 1 trillion tons. It's hard to envision these dimensions and volumes. For reference, the infamous iceberg that caused the Titanic sinking in 1912 was 2 million times lighter than A23A. According to senior scientists from the University College London, over the past decade, they've observed a steady decrease in the iceberg's thickness. It's been slimming down by 8 feet per year. However, this is not surprising, as the water temperature around the iceberg has been steadily increasing. Although scientists cannot yet predict exactly how long A23A will survive, they're confident that it will largely depend on its future path. Warmer air temperatures are expected to create pools of meltwater on the iceberg's surface, which will then flow down, creating cracks and leading to its eventual disintegration. Icebergs like A23A falling apart serve as a reminder of the serious threats hidden within Antarctica's ice masses. One of these threats, rightfully considered the most dangerous, the Thwaites Glacier, also known as the Doomsday Glacier. And it's earned that name for a good reason. Thwaites Glacier plays a key role in the stability of the West Antarctic ice sheet, and scientists believe if it melts, it could have catastrophic, irreversible consequences. And trust us, the scale of this problem is immense. The glacier's outlet area measures 75 miles along the coastline, making it the record holder for the widest glacier on the planet. It flows into Pine Island Bay in the Amundsen Sea, east of the dormant Mount Murphy. The Doomsday Glacier spans an area of 46,000 square miles, larger than the state of Florida. It also has a greater area than England, Wales, and Northern Ireland combined. Its depth at the base ranges from 2,600 to 4,000 feet. Next to it, even the massive A23A iceberg would seem tiny. But what's caused the instability of this glacier and its rapid melting? In 2014, the University of Washington allocated $50 million for research to determine the cause of the glacier's melting, and now we know a bit more. Until recently, the melting of Thwaites Glacier was attributed to human activity and the global warming associated with it. Although global warming has played its part, the primary cause lies elsewhere. Thwaites Glacier is being heated from the underground. Beneath the glacier, they've discovered geothermal activity, hot springs. This suggests there may be volcanic activity brewing under the glacier, since geothermal sources are always linked to volcanoes, and that is very bad news for us. In addition to geothermal activity, seawater is also melting the glacier from within. Seawater enters the glacier's base, accumulates, and moves through the natural channels or pools within its cavities. The seawater penetrates miles deep into the glacier and then, in accordance with the 12-hour tidal cycle, moves back out. As the ice melts, fresh water is flushed away and replaced with warmer seawater. Over the last 30 years, the glacier's ice loss has doubled. Today, Thwaites Glacier contributes to 50 billion tons of ice to the ocean annually. Nearly 80% of icebergs floating in the southern reaches of the world's oceans are fragments of Thwaites. This ice loss currently accounts for around 4% of the total global sea level rise. And on a planetary scale, that's a significant amount. The glacier continues to move steadily at a speed of 1.2 miles per hour. If that doesn't sound alarming, consider this. In January 2019, NASA discovered an underwater cavity beneath the glacier with an area 2/3 the size of Manhattan. This cavity is about 1,000 feet tall and likely accelerates the glacier's disintegration. What would happen if Thwaites Glacier collapses entirely? Well, the predictions are far from reassuring. Global sea levels could rise by 25 inches. This would trigger a chain reaction of dire consequences. Sea levels could rise even further, by as much as 10 feet, in case Thwaites pulls neighboring glaciers with it. This would lead to the flooding of coastal regions around the world. Recognizing these alarming stakes, the UK and the US established a joint international project in 2018 called the International Thwaites Glacier Collaboration, ITGC, to study the glacier and monitor its changes. That said, there's no need to panic just yet. It'll take several hundred years for the glacier to dissipate completely. We won't live to see the full extent of sea level rise, and over such a long period, humanity will likely find a way to counteract or adapt to the changes. Currently, as you watch this video, thousands of scientists and researchers are breathing in the cold Antarctic air, working tirelessly to gather new data about this icy continent. Their efforts are purely scientific, and for good reason. As early as 1959 in Washington, 12 countries whose scientists were actively conducting research in Antarctica signed an international treaty that agreed on complete demilitarization of the continent and its use exclusively for peaceful scientific purposes. This treaty is set to expire in 2048. However, even before it was signed, 7 different countries had laid 8 territorial claims in Antarctica, including the United Kingdom, France, Argentina, Chile, Australia, Norway, and New Zealand. Most of these territorial claims resemble pie-shaped sectors extending from the north to the south between the Antarctic Circle and the South Pole, collectively covering more than 80% of the white continent. Even Nazi Germany, long before this became mainstream, had laid claim to a large strip of land, which they named New Swabia. These territorial claims on a continent 98% of which is covered in ice might seem strange, but you shouldn't rush to conclusions. In addition to things being hidden underneath Antarctica that draw the attention of scientists, there's also something that piques the interest of political leaders. Earlier this year, Russia discovered vast reserves of oil and gas in Antarctica, most of which are concentrated in the Ross Sea region, claimed by the United Kingdom. The discovered reserves contain an astonishing 511 billion barrels of oil. This is about 10 times the amount produced in the North Sea over the past 50 years. It's almost double the total reserves of Saudi Arabia, which ranks second after Venezuela in oil reserves. At $70 per barrel, the oil reserves beneath Antarctica are valued at $35.7 trillion. This is greater than the GDP of China or the combined GDPs of the US and Russia for 2023. Furthermore, it's been revealed that in addition to oil and gas, Antarctica also contains deposits of oil, iron, gold, silver, and many other valuable minerals. In light of these discoveries, territorial claims by various countries are only expected to intensify. Attempts to claim territory on the white continent have sometimes involved strange and ambiguous methods. Argentina, in pursuit of its goal, thought that this difficult matter could be helped by a pregnant woman. In 1977, a woman was sent to the Argentinian scientific base with the ironic name Esperanza, which translates as hope. A few months later, a baby boy, Emilio Marcos Palma, was born there, becoming the first known person born on the icy continent. At the time, the Antarctic Treaty already guaranteed international governance over the territory, but Argentina hoped that their citizens, born in Antarctica, would make its claims more legitimate. Between 1978 and 1983, 8 Argentinian children were born in Antarctica, but ultimately, this had no impact. Nevertheless, the Antarctic Treaty remains in force and will continue to do so for another 24 years. As for what happens after it expires, we can only theorize. Antarctica remains the most mysterious and fascinating of all the continents on Earth. It's amazing how such a cold, icy world can hide so much important and valuable information for understanding the nature of our planet. But Antarctica is not the only place on Earth that holds many mysteries and unexplained phenomena. Most of us know Antarctica as a frozen tundra with places so cold that no human could survive without shelter. But global warming can affect things fast and transform entire continents. Those of you who are familiar with Earth's history know that during the time of the dinosaurs, Antarctica was a huge green forest. And now the icy continent is turning back into a green one because of global warming. It is a favorable environment for moss and algae. The process has already started. In some places, the ice isn't just green, but also red, orange, or brown. These are multicolored mosses, which spread fast. The sight is stunning, but green plants reflect less sunlight than a white surface, and their spread accelerates the melting of ice. So what does it mean for us? Recently, researchers collected limpet shells and penguin bones from the coastal strip and determined their age. This tells scientists when the ice disappeared from the beaches. And it turned out that the two major glaciers in Antarctica, Thwaites and Pine Island, are now melting faster than they did in the past 5,500 years. Because of this, sea levels are rising every year, and in 100 years, they will rise by 3.4 meters. In 2020, NASA scientists have discovered that glaciers are disappearing in other areas of Antarctica at an alarming rate. Over the past 25 years, Antarctica has lost twice as much ice as was previously thought, especially floating ice shelves. These ice shelves hold back melting ice, keeping it from flowing into the ocean. Since 1997, about 12 trillion tons of ice has melted. All indications are that Antarctica is going back in time to when it was still green. Paleontologists say that the continent was ice-free during the Cretaceous period, 145 to 66 million years ago. Back then, the ocean could heat up to 30 degrees, and in general, the temperature on the planet was higher than it is now. Most likely, the Earth was heated by numerous volcanic eruptions. Volcanoes were spewing lava that was deadly to all life and causing devastating fires. At times, the entire region was on fire, turning into a desolate, burned-out area. But in spite of everything, life thrived. Antarctica was home to the ancestors of mammals, reptiles, and the first birds and dinosaurs. In 1986, paleontologists discovered the remains of an Ankylosaurus on James Ross Island. The bodies of these giant lizards, about the size of an elephant, were protected by a heavy and thick armor made up of massive cones and bone plates. Their tail had a thickening, a kind of club, that easily broke the bones of an enemy when struck. Later on the island of Vega, scientists found the remains of hadrosaurs. They reached a length of 7.6 meters and a weight of about 8 tons. They had wide duck beak-like noses and hoof-like claws on their front legs. They had a hollow helmet on their heads. According to one version, it contained combustible gas. Like a dragon, the dinosaur ejected it in case of danger, somehow igniting it as it exited its nostrils. But so far this hypothesis hasn't been confirmed. In any case, both creatures were herbivorous and used their abilities for protection only. At the same time, there was also enough ruthless predators in Antarctica. One of them, the mosasaurs, also lived on Ross Island. Their remains have been identified among tons of ancient lizard bones recently discovered by paleontologists. Their razor-sharp teeth and powerful jaws allowed these monsters to tear their prey into pieces. They preferred marine reptiles, especially turtles and plesiosaurs. They even ate their own kind. Meanwhile, Earth grew colder and ice covered Antarctica for millions of years. But 56 million years ago, during the Eocene epoch, spring came to the continent again. The glaciers of Antarctica were once again replaced by forests. They contained palm-like Araucaria trees, conifers, and southern beeches. The thickets were inhabited by ancient relatives of today's marsupials, armadillos, and anteaters. On Seymour Island, paleontologists found the remains of a creature that resembled both a horse and a camel. And more recently, they found the bones of unusual birds, pelagonithodites. These large creatures were armed with sharp bone spikes protruding from the saw-like jaws. Such body structure helped the birds catch squid and fish. The Eocene-era inhabitants of Antarctica probably went extinct at the end of the epoch. Then the planet cooled again, and the continent was covered with ice. It now averages about 1.6 kilometers thick. It would seem no creature could survive under such icy mountains. But in recent decades, scientists have found something on the continent that changes the way we think about Antarctica. Beneath the ice, they've discovered multiple canyons, rivers, and lakes. There are about 400 lakes alone. One huge lake, the size of a modern city, was recently found using an airplane equipped with GPR, magnetometers, and some other tools. The lake, about 200 meters deep, was named Snow Eagle. It's 48 kilometers long and more than 15 kilometers wide. This is about the same size as the famous Flathead Lake in Montana. Researchers are now studying the inhabitants of such lakes. It's believed that they have been living under the ice for millions of years. Ukrainian scientist Andrey Kapitsa found a leech of unknown species, which has no equal among congeners. In a calm state, this terrifying creature is 35 centimeters long, but after sucking the blood of fish, it can increase 3 times in size. Another discovery was recently made by German researchers by drilling a hole 740 meters deep into the Ross Glacier. A remote-controlled robot submarine transmitted images of microbes, crustaceans, and strange fish. They have incredibly huge eyes, probably to better see things in the dark. Some of them are orange, others are black, and the largest fish found has translucent skin through which its internal organs could be seen. But if the water temperature in the subglacial waters rises even a few degrees, these creatures may not survive, and our planet would be in for a nightmare. If Antarctica melts, sea levels would rise about 70 meters, flooding coastal cities. The map by an international team of scientists shows in detail what areas would be affected. Here are just a few examples. The Atlantic coast will disappear along with Florida and the Gulf Coast. In California, the hills of San Francisco will become a group of islands, and the Central Valley will become a giant bay. Millions of people will be forced to leave their homeland in search of another home. But will the new world have enough food and water for everyone? Antarctica's ice makes up 70% of the world's freshwater supply. If it mixes with salty seawater, it will become undrinkable. The circulation of ocean currents, which affects atmospheric processes and the tectonic movement of the plates beneath the Earth, would change. Then fierce storms, huge tsunamis, and ceaseless volcanic eruptions will become the new norm. Some fertile areas will become deserts, while other places will be regularly flooded. It would be impossible to grow good crops or sustain large herds of animals under such conditions. There'll be less food to eat, and people will start fighting over a piece of bread. The outburst of epidemics will be another issue. Smallpox, bubonic plague, and anthrax will spread across the world. Some of these deadly germs will be alive. They've already shown themselves in 2016, when anthrax broke out in Yamal for the first time in 70 years. The epidemic took thousands of lives of reindeer and infected dozens of people. It's believed it was caused by an activation of microbes due to the thawing of permafrost, which accelerated during the summer heat. After all, everything may not be so tragic. Antarctica, which is a third larger than Europe, will prove to be livable, so the refugees can occupy this territory. Even when the ice clears the continent, there will still be plenty of space. The Antarctic Peninsula alone covers 522,000 square kilometers. That's more than twice the size of Great Britain. Indeed, some people will find shelter and will earn a living, for example by mining valuable minerals. Experts suggest that the continent is rich in deposits of oil, gas, silver, uranium, platinum, copper, and iron. But it is still the South Pole. For half a year, there will be no sunshine. Researchers believe that the area will be covered with cold swamps and lakes, as in some regions of Canada. Only mosses and lichens would survive there. And as for the livestock, only the hardiest species of musk oxen would survive. So productive farming and cattle breeding wouldn't be possible. So we better hope Antarctica stays white and scientists find ways to stop the glaciers from melting. The scientific community has considered artificially removing greenhouse gases from the atmosphere or limiting the amount of sunlight, but so far this seems too risky. Failure to intervene in the planet's complex climate system could lead to more problems, and the process could no longer be reversed. A team of scientists at the Massachusetts Institute of Technology has an idea to create a kind of protective raft of thin, bubble-like membranes in space over Antarctica. It will reflect or absorb part of the sunlight directed at Earth. The raft, with a width of thousands of kilometers, is planned to be placed near the first point of Lagrange. These are areas where the gravity of two massive objects, the Sun and the Earth, or the Earth and the Moon, holds the third object in a stable position. Calculations have shown that the reduction in the amount of light will be 1.5%. This is enough to overcome the effects of global warming. In addition, if the raft does not perform its functions or starts to cause harm, it can simply be dismantled. Although this is still just an idea and the project itself is still under development. Scientists have continuously surveyed much of the Antarctic surface since the early 20th century and have kept track of all the continent's ice shelves and their movements. In one such ice shelf, known as the Brunt Ice Shelf, they've recently discovered that an iceberg twice the size of New York City is poised to break away. A recent NASA release says that a crack has been growing at a rate of about 2.5 miles or 4 kilometers per year since 2012. The crack started from the southern part of the Brunt Ice Shelf and is steadily moving northwards and can soon meet with another growing chasm called the Halloween Crack that was discovered in October 2016, growing eastward from the McDonald's ice rumples in the northern part of the ice shelf. Although the Antarctica's ice shelves are in constant motion, rising with the tides, splitting off icebergs at its edges and growing again as inland glaciers feed it. But this type of anomaly is not regular at all for the Brunt Ice Shelf, as there has been next to no activity within the ice shelf. The glacier in question is around 1,700 square kilometers, or about 656 square miles, making it the fifth largest iceberg in the world that's currently being tracked by the National Ice Center in Suitland, Maryland. This news has sparked various safety concerns for scientists in the area, especially ones in the British Antarctic Survey's Halley Station. What exactly is driving these massive cracks to form in Antarctica's ice shelves? And what would be the effect on the ice sheet itself if this crack led to a complete breakage? Let's look at a similar situation that occurred in the last few years. A similar giant crack was discovered in the Larsen C ice shelf in 2016. It was the fourth largest ice shelf in Antarctica at the time. Just imagine, it had an area of 17,100 square miles or 44,200 square kilometers, which is an area larger than the state of California. But this crack was about to break off an iceberg with the length of 68 miles or 110 kilometers, a width of more than 300 feet or 91 meters, and a depth of 1,600 feet or 500 meters. More mysteriously, by mid-2017, in less than a year, the rift had extended another over 20 miles or 32 kilometers to a point where only 2 miles or 3 kilometers of unbroken ice remained, and breaking was an absolute certainty. And in mid-July, the iceberg finally broke off from the Larsen Sea ice shelf, taking away almost 13% of the ice shelf with itself. And as of April 2020, scientists reported A68 has broken up into 3 pieces and is floating northwards towards open waters. When it broke, the iceberg was one of the largest ever, twice the size of Luxembourg, and weighed in at almost 1 million tons. What's driving these huge breakages in Antarctica? And is Antarctica safe for now? Scientists are still trying to figure out this anomaly. Smaller carvings of icebergs are regular occurrences all over the shores of the continent. These carvings are very much natural occurrences, as losing icebergs to the ocean is how these ice sheets maintain equilibrium, balancing the inputs and outputs from ice streams in and around them. However, such large carvings from major ice shelves are not consistent with the natural pattern at all. Such large carvings leave the parent ice shelves unstable and more susceptible to breakages. There can be various reasons for such phenomenon. One definite reason for such occurrences is the accelerated climate change due to the rise of greenhouse gases over the last few centuries. Since the Industrial Revolution, the concentration of carbon dioxide has been rising exponentially at a rate of about 0.17% per year. This change is primarily due to the combustion of fossil fuels, but also to large-scale tropical deforestation, which depletes the climate system's capacity for photosynthesis. Climate temperature changes depend on the variations in the amount of carbon dioxide in the atmosphere. Carbon dioxide controls temperature because the carbon dioxide molecules in the air absorb infrared radiation. The carbon dioxide and other gases in the atmosphere are virtually transparent to the visible radiation that delivers the sun's energy to the Earth. But the Earth in turn re-radiates much of the energy in the invisible infrared region of the spectrum. This radiation is easily absorbed by carbon dioxide. When the carbon dioxide concentration is sufficiently high, even its weaker absorption bands become effective and a greater amount of infrared radiation is absorbed. As it prevents its escape into space, the trapped radiation warms up the atmosphere. Antarctica has experienced air temperature increases of 3 degrees Celsius in the Antarctic Peninsula. It's 5 times the mean rate of global warming, as reported by the Intergovernmental Panel on Climate Change. Over the past 50 years, the west coast of the Antarctic Peninsula has been one of the most rapidly warming parts of the planet. This warming is not only restricted to land, but also can be noted in the ocean surrounding it. Upper ocean temperatures to the west of the Antarctic Peninsula have increased over 1 degree Celsius since 1955. Thus, ice shelves in western Antarctica are particularly susceptible to warming oceans, as relatively warmer water eats away at the ice shelves floating over the ocean. Since 1992, it's averaged a net loss of 65 million metric tons of ice a year. One of the defining characteristics of West Antarctica is that the majority of the ice sheet is grounded on a bed that lies below sea level. When the ice sheet is attached to a bed below sea level, ocean currents can deliver warm water to its grounding lines, the location where the ice sheet attaches to the bed. In some spots, the bed lies more than 1.5 miles below sea level. When these grounding lines start to retreat, ocean water can infiltrate between the ice and the bed and cause the ice sheet to float off its grounding line. Scientists recognized that this is the first step in a potential chain reaction. Ocean heat eats away at the ice, the grounding line retreats inland, and ice shelves lose mass. And when ice shelves lose mass, they lose the ability to hold back the flow of inland glaciers, meaning those glaciers can accelerate and thin out as a result of the acceleration. This thinning only leads to more grounding line retreat, more acceleration, and more thinning. In all, this push and pull, sudden fractures can occur, leading to massive breakages of icebergs like the one currently taking place in the Brunt ice shelf. Once these icebergs break away from its parent mass, it becomes more exposed to warmer ocean currents and melts faster. And as more ice flows into the ocean every year, it leads to an eventual rise in global sea levels. This is the biggest fear among scientists with climate change. For example, the Amundsen Sea region of West Antarctica, which is the most vulnerable to the rise in ocean temperature, contains enough ice to raise global sea levels by 4 feet, 1.2 meters. The most recent UN Intergovernmental Panel on Climate Change report estimates that by 2100, sea levels will rise somewhere from just less than 1 foot to about 3 feet or 26 to 98 centimeters. But the vast majority of these projections do not take into account the possibility of major ice loss in the form of massive breakages in Antarctica. The Amundsen Sea region is only a fraction of the whole West Antarctic ice sheet, which, if melted completely, would rise global sea levels by about 16 feet or 5 meters. This eventual sea level rise will have a profound impact on our civilization as we know it today. In the extreme scenario, if most of the Antarctic ice melts, the existing coastline of our present continents will be completely unrecognizable, raising the sea level by 216 feet or 66 meters. In North America, the entire Atlantic seaboard would vanish, along with Florida and the Gulf Coast. In California, San Francisco's hills would become a cluster of islands, and the Central Valley a giant bay. The Amazon Basin and the Paraguay River Basin in South America would become Atlantic inlets, wiping out Buenos Aires, coastal Uruguay, and most of Paraguay. Although Africa would lose less of its land to the ultimate sea level rise. However, in Egypt, Alexandria and Cairo will be swamped by the intruding Mediterranean. In the European continent, London would have been completely swallowed underwater. Venice will be reclaimed by the Adriatic Sea. Netherlands will have long since surrendered to the sea, and most of Denmark will be gone too. Meanwhile, the Mediterranean's expanding waters will also have swelled the Black and Caspian Seas. Asia would be completely changed as well. Land now inhabited by 600 million Chinese would flood, as would all of Bangladesh and much of coastal India. But how to predict these sudden anomalies and whether these big calving will lead to a collapse of the ice shelf itself? At present, the anomaly under the Brunt ice shelf is still progressing, and both cracks are moving towards one another. This has allowed scientists to take some risks and monitor the process in great details. This research has already yielded a lot of new data and prediction models to further explain these anomalies under the ice sheets of Antarctica. That's all we have for you today, folks. Subscribe to our channel to keep getting videos exploring the latest scientific news around the globe. Also hit the notification bell so you're notified every time we release a video. Thanks for watching.